Hi, and welcome to Geometry 1. Today we're going to start off with section 1-1, which is patterns and inductive reasoning. We'll go through a series of examples and go over some vocabulary words and hope you understand. So we're going to start off with inductive reasoning, and inductive reasoning is making a conclusion based on examples and patterns. So we're going to do a couple of examples right now that uses inductive reasoning to determine the next few terms in a sequence. Okay, so we'll start with example A. Okay, so example A says find the next three terms of the sequence, and it gives us 1.25, 1.45, and 1.65. Looking at these numbers, we're trying to find a pattern, and looking for a pattern is using inductive reasoning. Looking at these, I can notice the pattern of addition. It looks like the difference between these two is 0.20, and then again the difference between these is 0.20. So each time they're adding 0.20. So using inductive reasoning, based on the pattern that we found, I'm going to guess that our next three numbers, or next three terms, are going to be adding 0.20. So I'm going to add 0.20 to 165 and then continue on that for the next three terms. So 1.65 plus 0.20 is 1.85, and then I'm going to add another 0.20, and that'll give us 2.05, and then again I'm going to add 0.20 one more time, and that'll give us 2.25 to give us the next three terms in the sequence. So again, I looked for a pattern, I found that pattern, and then I used that pattern to determine the next three terms. Okay, we're going to go through another example. If you want to try the example on your own, press pause at this point, and press pause after I write the problem on the board, and then you can try to go through it, and then you can watch it and see if you got the correct answer. Or if you still feel that you need help, then just continue to watch, okay? Okay, so if you want to try this on your own, go ahead, press pause. But we're going to continue to go through it. So for B, it gives us the terms 13, 8, and 3. And so looking at this, we're not adding this time, but it does look like we're subtracting. So the difference between this is minus 5. We're subtracting 5. And then the difference between this, it looks like we are, again, subtracting 5. So based on inductive reasoning, the pattern that I found, it looks like they're subtracting 5 each time, so I'm going to subtract 5 to find our next three terms. Okay, so 3 minus 5 is negative 2. Negative 2 minus 5 is negative 7. And negative 7 minus 5 is negative 12. And then again, we have our next three terms. Okay, we're going to go through about 5 examples, I think, and hopefully you guys will understand the patterns and inductive reasoning. So we'll go on to example C. Press pause if you want to try this on your own. Okay? So for C, we have the numbers 1, 3, and 9. For these ones, we can check the difference between them. So right here from 1 to 3, we're adding 2. And from 3 to 9, we are adding 6. And so unlike A and B, this one does not have a common addition or common subtraction. So we're not going to have to go that route. The pattern is not addition or subtraction. But looking at this, I can notice that each time it looks like we're multiplying by 3. So 1 times 3 is 3, and 9 times 3, or 3 times 9, sorry, is 9. So it looks like we have a pattern of multiplication timesing by 3. So I'm going to times by 3 on the next 3 terms, and hopefully we'll have the last one. So 9 times 3 is 27, and 27 times 3 is 81, and 81 times 3, I can't do it in my head, so I'm going to do it on the board. 81 times 3 looks like it's 243. So we used the pattern of multiplying by 3 each time, and we were able to find the last 3 terms. Okay? We'll move on to example D. Okay, so looking at example D, it looks like we have 32, 16, and 8. I can already tell that the difference between them are not the same, so it's not addition or subtraction. But it does look like I'm noticing that we're dividing each time. So 32 divided by 2 is 16, and 16 divided by 2 is 8. So it looks like our pattern is dividing by 2 each time, and so to find my next 3 terms, I'm going to again divide by 2, okay? So 8 divided by 2 is 4, and 4 divided by 2 is 2, and 2 divided by 2 is 1, okay? So this one, we used inductive reasoning, we found the pattern, and we concluded that our final 3 terms were, final 3 terms were 4, 2, and 1. Okay, so let's move on to example E. Okay, so for E, it gives us 10, 12, 15, and 19. If you want to go ahead and try this one on your own, press pause, and I'm going to go through the example, but then you can check your work after, okay? So looking at this one looks a little bit trickier than our other ones, but we look like the difference between here, we're adding 2, and then it looks like the difference between here, we're adding 3, and then it looks like the difference between here, we're adding 4. So unlike our other ones, there's a different kind of pattern. We're adding by 1 more each time, it looks like to me. So then what am I going to add on the next one? 1 more than 4, which is 5. So 19 plus 5 is 24. And we're going to add 6 on the next one. So 24 plus 6 is 30. And then again, 30 plus 6 is, we got to do 7. 30 plus 7 is 37. Okay, so this one was a little different than the previous problems, but we still found the pattern, and we just applied our inductive reasoning and found our last 3 terms of the sequence. And so we'll move on to question F. Okay, so this one, it looks a little tricky again, but I'm going to go ahead and take a guess, okay? So from this one to this one, we times by 2. From this one to this one, we times by 3. from this one to this one, we times by 4. So it looks like we're multiplying by the addition of 1 each time. So if I'm looking at this one, we got to do 24 times 5, and I don't know that in my head, so I'm going to do 24 times 5 right here on the side. So 5 times 4 is 20, 5 times 2 is 10. So 120 looks to be our next term, and then it looks like we need to multiply by 6. So we're going to multiply by 6. Again, I'm going to do this one on the side. So 120 times 6. And I get 720. And then the last one, it looks like we got to multiply by 7. So I'm going to do 720 times by 7, and that'll give our third term. And it looks like we have 5,040. Okay, so we times by 2, times by 3, we times by 4, we times by 5, we times by 6, and then we times by 7. So we noticed the pattern, and we found our final 3 terms, which are these 3 terms here. Okay, I think we're going to do one more example, and hopefully you guys get it. Okay, so G is a little different than our previous examples. All of our examples use numbers. This one is actually trying to notice a pattern using these shapes. The first one we have is a triangle, and the second one we have is a triangle with a circle on side of it. And then the third third figure that we have is a triangle with a circle inside of it with a triangle inside the circle. And so looking at this, I'm going to guess that our next pattern is going to have a circle inside the triangle, just how this one did here. So our next term looks like circle, triangle, circle. It's going to get a little bit small, so hopefully you guys think the same as me. And it looks like the next one is going to be triangle, circle, triangle, circle, and then I'm thinking another triangle inside the circle again. And then our very last one, it looks like to me, is we're going to have a triangle, a circle, a triangle, a circle, a triangle, and then lastly like a little tiny circle inside of there. So just a recap of what we did in this section. We used patterns to determine what the next 3 terms of the sequence are, and using examples and patterns is using inductive reasoning. Okay, after this I'm going to have a slide for you guys with some important vocabulary, so if you guys want to take notes after all of the example problems that we did, go ahead and put down these important vocabulary terms. They're really important for section 1 of patterns and inductive reasoning. Thanks.